Welcome to Freshers World YouTube channel for jobs and careers. This is Tanuja here, and today we would be going through some basic problems based on heights and distance. In my previous video, I had gone through the basic formula and some of the important terms required to solve the questions in height and distance. So today we'll be doing some basic problems on them. Let's move on to our first question. See, our first question is, a kite flying at a height of 45 meter from the level ground is attached to a string inclined at 60 degree to the horizontal. So our question is, find the length of that string. Okay, see, from this question, the first thing, if you get any question, the first thing that you need to do is first draw the diagram. From the diagram, it will be very easy for you to solve the question in height and distance. So let's begin with drawing the diagram. A kite flying at a height of 45 meter from the level of ground attached to the string inclined at 60 degree. So see, the height it is saying as 45 meters. So let's consider this is 45 meter height. From this point, a kite is flying at this point and it is inclined at 60 degree from the horizontal. So this is the kite, this is the string, and it is inclined at 60 degree from the horizontal, and the height from the ground is 45 degree. This is what the question is saying, and what it is asking for, it is asking for the length of the string. Let's say length of the string is x. So you see here, from the question we got this angle as 60 degree, we got this height as 45 meter. So what is this height? This is the perpendicular, and what we need to find is the hypotenuse, which is opposite to 90 degree, and this is base. Okay, so like we said in our last video, any right angle triangle will have one angle as 90 degree. The sum of all the angles in a triangle will be 180 degree. So if this is 90, this is 60, so obviously this will be 30 degree. See, now we have all the angles laid out. We have one of the sides is 45 meter and we need to find the hypotenuse. So we have the hypotenuse, we have the perpendicular. So what should be the formula which relates both these hypotenuse and the perpendicular? Yes, you guessed it right, it's sine theta. So sine theta equals to perpendicular by hypotenuse. So if we put all the values in this equation, it will be sine 60 degree, perpendicular is 45 and hypotenuse is x. So and we know that sine 60 degree is root 3 by 2. So root 3 by 2 equals to 45 by x. So finally x would be 45 into 2 by root 3. So now we got x equals to 45 into 2 by root 3. So this, if we simplify it further, we can say 15 into 3 into 2 by root 3, which is, again we can do it as root 3 into root 3 into 2 by root 3. Root 3 if we cancel, so we get as 30 root 3, which is the answer. So finally we got that this side or the length of the string is 30 root 3 meter. So you saw how by putting all the formula and all the equations we finally got out this answer. See, it's very simple. If you know the formula, where to put in and how to find it out, it's very easy to solve problems in height and distance. Now, see, this was the conventional way how we solve any height and distance problem. But now, I'm about to show you a trick which will make this problem very easy, and it will also save a lot of your time. Let's try that. For that particular trick, you need to remember two ratios. Two set of ratios you need to remember for that thing. So first ratio is this is the first ratio. 30 degrees to 60 degrees to 90, which is equal to 1:3:2. You need to remember first this set of ratios, and the second one is 45 degree, 45 degree and 90 degree, which will be 1:1:2. These two sets of ratios you need to remember for the trick which I am about to tell you. So just note it down somewhere, these two. Hope you all noted it down. Let's implement this trick in a problem. So let's try to implement this trick on the same problem we just solved. So as you remember, this is the diagram. Here we had 45 meter, this was 60 degree, and we had to find x. So we have 60 degree, we have 90 degree, and this is 30 degree. 30 degree, let's say it is y. From the problem we had these two values, 45 meter and 60 degrees. And let's consider this as x, and since we don't know the base also, let's consider it as y. Now let's try the ratio. Okay, from the ratio we have 1:3:2. Now, so let's try to implement this equation or this ratio into this problem. So the side opposite to 30 degree, side opposite to 30 degree is y, the side opposite to 60 degree is 45, and the side opposite to 90 degree is x. Now the known value here is 45. Let's try to equate this 45 with all these three values. So if √3 is 45, then 1 will be 45 by √3. So here we get 45 by √3. If 1 is 45 by √3, then what will be 2? 2 will be 45 into 2 by √3. So we get here 90 by √3. So you see, just by putting it in this ratio, we got all the three values, all the three sides we got. We got y equal to 45 by √3, and we got x equal to 90 by √3, which we required. Now 90 by √3, how will it become 30 √3? It is very simple. If we try to simplify 90 by √3, it will become 30 into 3 by √3, which will again become 30 √3 into √3 by √3. So here we got finally 30 √3. It was the same answer when we tried to find the solution of x from the conventional method. So this proves the authenticity of this trick that I was trying to tell you. Let's try a new question and try to implement this ratio in that new question also and try to find the answer. Now moving on to our next question. The question is, a person is trying to look at the tip of a tower of height h with an angle 60 degree. The person is standing at a distance of 10 meter from the foot of the tower. Find h. So first of all, let's draw the diagram. So a tower of height h. This is a tower of height h. Now a person is standing at a distance of 10 meter from the foot of the tower. So maybe the person is standing here and he is at a distance of 10 meter from the foot of the tower. Now this person is trying to look at the tip of this tower. This is the tip of the tower, and a person is trying to look at this tip with an angle of 60 degree. This is the line of sight of that person. And what we need to find in this question is h. Now we have 10 meter, we have 60 degree. So like always, this will be 90 degree and this will be 30 degree. So we have 30 degree, 60 degree and 90 degree, and we have 10 meter and we have h. When we try to put these values in that ratio, that ratio, then how would we get the answer? Let's try. So 30 degree, 60 degree, 90 degree, which is 1, √3, 2. Now the side opposite to 30 degree is 10. Let's put 10 here. Then what will be 60 degree? It will be 10 √3. What will be 90 degree? It will be 20. So 10, 10 √3 and 20. Now what was the question? The question was to find h. And where is h? H is the opposite side to 60 degree, which is this. So see, simply by putting the values in this equation, we found out h. H is equal to 10 √3. H equals to 10 √3. You saw how simply we found the answer for this question just in a minute. So h will be 10 √3. Now let's try one more problem like this. So a third question. So a third question is, we have a tower of height 10 meter and the person is sitting at the top of the tower and is looking at an object which is placed in the ground with an angle of 45 degree. So the question is to find the distance of the object from the foot of the tower. See here, the person is sitting on the top of the tower, means this is the angle of depression. So you remember how we used to draw the angle of depression? Similarly, we will be drawing it here. So this is a tower, it is of height 10 meter and the person is sitting here and he is looking at an object which is placed here. Let this object be P. Okay, and he is looking with an angle of 45 degree. So angle of depression would be 45 degree. So from my previous video, we found out that if this is 45 degree, then this will also be 45 degree. So we have this 45 degree and like always, this will be 90 degree and this will again be 45 degree. So now in this problem, we will be using our second set of ratios, which is 45 degree, 45 degree and 90 degree, which is 1:1:√2. Now using this value, you see this 45 degree angle, the side opposite to 45 degree is 10. We place here 10, then this will again be 10 and this will be 10√2. And what was the question here? The question was find the distance of the object from the foot of the tower. The foot of the tower is this and this side is opposite to 45 degree and side opposite to 45 degree is 10. So simply using this equation, we found out this distance, the distance of the foot of the tower and the object is again 10 meter and this is 10√2. See, also there is one more result that I had mentioned in my first video, which we can use it here. It is very simple. If the angle of depression, the angle of elevation is 45 degree, so simply close your eyes and simply the perpendicular will be equal to base. From that result also we can authenticate this formula. So fourth question. A person at point A is looking at the tip of the tower at an angle of 30 degree. Then that person moves a little closer to the tower and reaches to point B. From point B, he is looking at the tip of the tower with an angle of 45 degree. And given the height of the tower is 12 meter. So what will be the distance from point A to point B? This is our question. So let's first draw the diagram. The tower is 12 meter. Then a person standing at point A is looking at the tip of the tower with angle of 30 degree. Then he moves a little closer to the tower and reaches point B, and he looks at the tip with an angle of 45 degree. And we need to find this distance A and B. This distance A and B. This is what the question is. Okay. So first of all, let's take first triangle ACD. Triangle ACD. In this triangle, you see, this is 30 degree, this is 90 degree. So this whole angle will be 60 degree. Okay. Now, in the second triangle, which is BCD, this is 45, this is 90. So this will be 45 degree. So we got all the angles. So let's start with angle ACD. In angle ACD, again, if we put it in the equation 30, 60 and 90 ratio, which is 1√3, 2. We have this as 12. 30 is 12. Then 60 will be 12√3 and 90 will be 24. So from this we got this side AD. AD is the side opposite to 60 degree. So from this equation we got AD equals to 12√3. Let's write it down here. AD equals to 12√3. Now let's take a second triangle, which is BCD. Triangle BCD. Again, if we put the values in the equation, that is 45 degree and 90. It is 1 and √2. So again, the side opposite to 45 is 12. So this is 12, this is 12 and this is 12√2. So again, from this equation we found out that side BD, which is opposite to 45 degree, is 12 meter. So from the first triangle we got AD equals to 12√3, and from our second triangle we got BD equals to 12 meter. And what was our question? Our question was to find the distance between AB, which is this. This distance is what we had to find, and what all values we got? AD. AD is this complete value, and BD. BD is this value. So how will we get AB? AB will be equal to AD minus BD. AD is 12√3 and BD is 12. So the answer will be 12√3 minus 1 meter. See how simply using these two equations we found this answer too. So that is what I was talking about. There are conventional ways to solve the problems in height and distance, but if you use this formula, you can solve the questions in much lesser time. In my next video, I'll be talking a little more tougher problems on height and distance. See, in my first video I had mentioned about the basic formulae and basic terms that are required to solve the problems in height and distance. In this I had discussed about the basic or the normal questions that come in height and distance. Thank you for watching this video. For those who are looking for jobs, please register to freshersworld.com. Please don't forget to like and subscribe our channel if you want to see more such videos. Once again, thank you and have a nice day.